Hey there, my name is John Burney, and welcome back to Machine Health 101. Today, we're shifting gears a bit to talk about a critical application in HVAC systems, air handling units, and how to monitor them effectively for predictive maintenance. Air handling units, or AHUs, are essentially the heart of most central air conditioning systems. They regulate airflow, temperature, humidity, and air quality, making them critical in a wide range of environments. You'll find AHUs in pharmaceutical cleanrooms, biotech labs, data centers, hospitals, food processing facilities, manufacturing plants, and virtually every commercial building. In many of these applications, even small deviations in environmental conditions can lead to product quality issues, equipment failures, and compliance risks, which is why effective monitoring and maintenance of AHUs is so important. Monitoring air handling units comes with a unique set of challenges. Here are the primary issues we've encountered and how to overcome them. Challenge 1. Inaccessibility. AHUs are often fully enclosed and located in hard-to-reach areas. This makes it nearly impossible to access key monitoring points like the bearings while the machine is running. And trying to place a wireless sensor inside the AHU usually doesn't work out, as the metal housing and internal obstructions often block wireless signals from getting in or out. The solution is to use a hybrid wireless and wired setup. We can mount a wireless transmitter on the outside of the AHU while wiring sensors directly to the internal components, like motor or fan bearings. Challenge 2. Multiple fault modes. Mechanical issues like bearing wear or belt misalignment are only part of the picture. It's recommended to monitor additional parameters like airflow and motor health, especially in regulated environments like pharmaceutical manufacturing. The solution is to take a holistic monitoring approach that captures vibration, temperature, motor current, and differential pressure to catch mechanical, electrical, and process-related faults, including clogged filters. Challenge 3. Variable operation. Most AHUs operate at variable speeds and under variable loads to meet demand. Without knowing the operating context at any given time, it's difficult to baseline what normal looks like in terms of vibration or temperature data. The solution is to include running speed in your monitoring strategy. This can be captured either by a field-mounted magnetic flux sensor or integrated from a process historian system, giving you the context needed for interpreting different trends. So what does an effective AHU monitoring system look like? The most practical and scalable approach uses a combination of wired sensors and wireless transmitters. A wireless transmitter is mounted outside the AHU enclosure to ensure a strong signal and reliable data transmission. Inside the unit, wired industrial sensors such as vibration, temperature, or differential pressure sensors are placed at key components like the motor and fan bearings. If the AHU is driven by a variable frequency drive or a VFD, it's important to also capture running speed data. This can be done using a magnetic flux sensor mounted on the motor or by integrating speed signals from a building automation system or a process historian. This setup allows you to collect all the critical condition data and transmit it wirelessly for real-time analysis. It also provides the context needed to diagnose faults accurately and detect emerging issues as early as possible. Here are some real-world examples of how facilities have used this exact monitoring setup to identify and resolve AHU issues before they led to failure. At a pharmaceutical R&D facility, a critical air handling unit began showing subtle signs of abnormal vibration. The unit was responsible for maintaining temperature and air quality in a cleanroom, an environment where even a small deviation in airflow or humidity could disrupt testing protocols and compromise product integrity. The monitoring system initially alerted the team about elevated vibration levels and acceleration, along with abnormal crest factor and demodulated spectrum values, all pointing towards a potential bearing fault in the motor. Because these changes were caught early, the site was able to schedule a quick maintenance intervention during a planned downtime window. After the bearing was replaced, vibration levels dropped significantly from 1.6 G to 0.2 G. validating both the diagnosis and the impact of early action. More importantly, it prevented what could have been an unexpected shutdown of cleanroom operations, preserving productivity and regulatory compliance. At another facility, engineers began noticing abnormal vibration patterns coming from an AHU fan motor. The overall vibration level wasn't excessive, but the vibration spectrum showed a persistent 2x belt frequency. This kind of signature often points to issues with belt wear, tension, or alignment, all things that can lead to increased energy use, overheating, and eventually a catastrophic failure. Maintenance teams took a closer look and discovered that the belts had stretched over time, and the alignment between the motor and fan pulleys had drifted slightly out of spec. By correcting both issues, the facility was able to restore normal operation and eliminate the risk of a potential failure down the road. Sometimes, the root cause of a machine health issue isn't mechanical, and that's where multiple parameters come in handy. In this case, an AHU began showing a gradual increase in vibration at the motor drive end. At the same time, the system also saw a rise in differential pressure across the filter. These two trends together triggered a maintenance notification, and upon inspection, the team found that the filter was completely clogged with dust and debris due to nearby construction, which caused excess dust buildup. If left unchecked, the clogged filter could have restricted airflow, caused motor overload, or led to temperature and humidity controls being thrown off. But with early detection, the team was able to change the filter, rebalance the belts, and bring the system back into optimal range, avoiding both equipment damage and product risk. Now let's quickly recap what we covered. AHUs play a critical role in maintaining environmental control, especially in clean rooms and other regulated facilities. Monitoring them comes with challenges, like inaccessible enclosures, the need for multiple sensing parameters, and variable speed operation. The solution to many of these challenges is a hybrid approach that combines wired sensors and wireless transmission for comprehensive data collection and real-time insights. And as we saw in various real-world scenarios, early detection through vibration, temperature, pressure, and other signals can help prevent costly failures and maintain operational continuity. When it comes to air handling units, the key to smarter maintenance isn't just more data. It's the right data, in the right context, delivered early enough to take action. By using a holistic monitoring strategy, facilities can reduce the chance of unplanned downtime, protect their critical assets, and stay ahead of potential failures, all while gaining better control over HVAC performance. Thanks for tuning in, and if you found this helpful, be sure to subscribe for more practical tips on condition monitoring, predictive maintenance, and best practices in asset reliability.